Now that we understand what p-values are, let's dive into how we calculate them. The calculation of p-values depends on the statistical test being used and the nature of the data. Common tests that yield p-values include the t-test, chi-square test, and ANOVA, among others. To calculate a p-value, you first need to determine the test statistic, which varies depending on the test. For instance, in a t-test, the test statistic is the t-score, calculated from the sample data. Once you have the test statistic, you compare it against a statistical distribution, such as the normal distribution for z-scores, or the t-distribution for t-scores, to find the probability of observing a statistic as extreme as, or more extreme than, the observed value. This probability is the p-value. It's crucial to ensure that the assumptions of the statistical test are met before calculating the p-value. For example, the t-test assumes that data is normally distributed and that samples have equal variances. Failure to meet these assumptions can lead to an incorrect p-value. Let's illustrate this with a practical example. Suppose we have two sets of data representing test scores from two different teaching methods. We can use a t-test to determine if there's a significant difference between the two methods. We calculate the t-score and then determine the p-value to assess the significance of the results.